All right, so there's two different settings here for number one. For each of the following situations, determine whether or not the given random variable has a binomial distribution. What are the four things we need to check? Or what's the acronym that we use to remember the four things we need to check? BINS. What does the B stand for? Binary. I. Independent. N. Number of trials has to be fixed. And S. Same probability of success each time. So with the whack-a-mole game, do we meet the binary? Yes, because you either whack the mole or you don't whack the mole. So this is binary. Do we get independence? Yes, and I highlighted why. Each try is not affected by the previous mole. It says your ability to whack any particular mole is not affected by whether or not you whacked the previous mole. That is the same way as saying each of these whacks is independent. Is the number of trials fixed? Is the number of trials fixed? Yes. How many trials? 20. S. Same probability of success each time. Do we have the same probability of success every time you go to whack the mole? Yes. What is that probability of success? 80%. So P is 0.80. Is this a binomial situation? Yes. This is binomial. Moving on to more arcade games. Next, you play skee ball. You know you have a 10% probability of getting any given ball in the 100-point hole. Let y equal the number of balls you must roll until you get one in the 100-point hole. So let's look at bins here. Do we get binary? For our random variable y, do we get binary? Yes. What's the success here? You get it in the 100-point hole. Failure would be anything else, right? Do we get independence? Do you think each roll is independent of the one before it? Yeah? Is the number of trials fixed? What'd you say? With the way they've described this? No. What did they say about this random variable? Until you get one in the 100-point hole. So you might have to play more than one game in order to do this. But the random variable is we're going to roll this until we get it in the hole. So is this a binomial random variable? No. Not binomial because the number of trials is not fixed. Whenever you see an until this thing happens, that's not going to be binomial. Question number 2. Now you play a game called Tsunami Duck Pond, where there are 100 ducks that get pummeled by tidal waves. Among the 100 ducks, there are 20 with stars on the bottom, 30 with circles, and 50 with squares. You must reach your hand into the tsunami and randomly select a duck. If there's a star on the bottom of the duck, you win. After you select each duck, you must place the duck back in the tumultuous water. Is this binomial? Is our Tsunami Duck Pond game a binomial random variable? Do we have binary, success or failure? What's the success? There's a star on the bottom. What's a failure? Anything else, not a star. All right, so we have binary. Are we independent here? Is each duck independent of the next? Yes. You are placing the duck back in the water, so there's still 100 ducks in there. You've got the same probability each time. What is the number of trials? 10. It says you play this game 10 times. What's the probability of success? 20%. 20 out of 100. 20 of the ducks have stars on the bottom. The remainder do not, and there's 100 ducks total. So let's find the probability that you win exactly 3 times. Probability that you win exactly 3 times. So we want the probability that W equals 3. What pieces? There's 3 things that I need here. What pieces do I need so that I can calculate this? You said N what? NP? First I need to know how many different ways we could win 3 times, right? So that would look like this. We're going to play how many times? 10. We want how many wins? 3. What's the probability that we win? 0.2 or 0.20. We're going to take that to what power? 3, because we want exactly 3 wins. Times the probability of failure. What's the probability of failure? 0.8. It's 1 minus 0.2. To the power of 7. Why 7? That's the number of failures. These 2 numbers added together should always give me however many total trials we had. I know how to put the 0.2 to the 3rd in my calculator. I know how to put the 0.8 to the 7 into the calculator. How do I put this into the calculator? That was the NCR. Do you guys remember pushing the math button and arrowing over to probability? That's what you have to do for this one. So this is the way you would type it into the calculator. What is 10C3? 120. So you can put it into the calculator just like this, or you can calculate 10C3, get this, and then put it like that into your calculator. Thank you. What do we get as our probability? I got 0.2013. All right. Remember, these 2 numbers here add together to give us the total number of trials. All right. Let's flip it over to page 13 now. Are you having trouble getting that answer? Okay, so you go put in the 10 first. Math. Arrow over to probability. There's the NCR. And then you put how many wins you want. There you go. All right, so page 13. Pop quiz. Right now. Hope you're ready. The quiz consists of 5 multiple choice questions. You guys have room to answer those 5 multiple choice questions right here. Each question has 4 answer choices, A, B, C, D. Bad news. I'm not going to tell you what the questions are. Take your best guess. Go. You guys have like 30 seconds. Take your best guess. coming. So it wants a multiplication right there. Otherwise, it thinks that you want 3 times this number of wins. You guys got your answers? Awesome. I'm going to read off the right answers, and I want you to write down how many you get correct right here. Number 1 was A. Number 2 was C. Numbers 3 and 4 were both D. Number 5 was B. Write down how many you got correct on the line. If I let my random variable x equal the number of correct guesses, is x a binomial random variable? What are the 4 things I need to check? Is it binary? Independent? Number of trials has to be fixed. Same probability of success each time. Let's go through and check those 4 pieces here. Is this binary? Yes. What would a success be? Answer correct. And failure? Wrong answer. Do we get independence? Does your result to question number 1 affect whether or not you got question 2 right or wrong? Ooh. No. So these are independent. Was the number of trials fixed? Yes. How many trials did you have? 5 trials. N is 5. Same probability of success each time. What's the probability of success? 25%, 0.25, or 1 out of 4. Thank you. I want you guys to calculate the probability of getting exactly 2 answers correct. We just did this on the previous page. We had just done this on number 2, part B. I want you to calculate the probability of getting exactly 2 questions correct. Or the probability that x equals 2. What 3 things do I have to put into the calculator? Yep. How many ways are there to do this? Which we represent like this, 5 over 2. No fraction, though, just parentheses with 5 on top and 2 on the bottom. And then what do we need? Probability of success, so 0.25, to the power of 2. Why to the power of 2? That's exactly how many successes we want. Then what do we multiply by? Probability of failure. If I have a 25% chance of success, what's my probability of failure? 0.75 to the power of 3. Again, I know how to put the 0.25 squared and the 0.75 cubed into my calculator. How do I put the 5 and 2 thing in my calculator? Math, and then over to probability, NCR. So you need the 5 in front, and then the 2. I want you guys to verify that you can get 0.264 when you put this into your calculator. It's independent because since you didn't know what the questions were, your chance of getting question 2 right did not depend at all on whether or not you got question 1 right. If you are using the app on your phone, I'm going to ask you to go back and grab one of the graphing calculators in the back, because this next thing I'm going to show you is a paid feature on the app, but it is not a paid feature on the actual graphing calculators that we have in the room. So grab an actual graphing calculator for me. For binomial random variables, not for other kinds of random variables, but for binomial random variables, we have a shortcut that will calculate this for us. To calculate the probability that x equals exactly 2, we're going to use a function on the calculator called binom PDF, and I'll show you where that is in just a second. This takes 3 pieces of information. We have to feed this function what our n value is, what our p value is, and the number of successes we're looking for, so what our x value is. I know that's way down at the bottom of the screen. I apologize, guys. I'm going to show you where this function is on the graphing calculator, and we're going to do this together. And then you're going to use it several more times to do number 4. Do you guys remember where we go to get the normal CDF? My thing is taking a minute. All right, so from this screen, you have to be on this screen right here. You can't be in a table. You can't be in a y equals. You have to be on this screen, just blank screen. If you're not here, second and mode will take you to this screen every time, no matter where you're at. So second and vars, so that you go into the distributions. We're going to scroll down, 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 down. Do you guys see right here where it says A and it's binom PDF? We want the one with the P. Binom PDF. And then it prompts you number of trials. We had 5 trials. Probability of success was 0.25. And we were interested in exactly how many correct? Exactly 2 correct. So I'm going to put 2 here. Depending on your graphing calculator, if it does not give you prompts like this, you still need these 3 numbers, and you're going to separate them by commas on the calculator. We're going to paste that in, so that's what it should look like on everybody's calculator, regardless of type, as long as it is a TI graphing calculator. And then we're going to hit enter. And when you round that out to 3 decimal places, you get what? Yep. 0.264. So hop 0.264. If you're using the app on your calculator on a problem like this on the homework, you're going to have to do that out long form, because the calculator will do the NCR. The app will. Calculator, unless you want to pay for it, does not do binom PDF. You could set it up, and then when you get into the classroom, grab one of the graphing calculators in the back and calculate it very quickly. That would be fine. I want you guys now to fill in the rest of this table. We just did this piece. So I want you to use the binom PDF to find the probability of getting exactly 1 question correct. Sorry, exactly 0, exactly 1, exactly 3, 4, and 5. I'm only going to give about a minute to do this. scientific notation? Do you remember how to do it?
Not at all.
Okay. You can hold off on that last one then. If your calculator gives you scientific notation for the very last one, and you don't remember how to change that into just decimal form, not scientific notation, you can hold off on that one. What do we get for the probability of getting 0 correct? 0.237. Exactly 1? 0.396. We already had 2. Exactly 3 correct? 0.088. Exactly 4 correct? 0.015. And then for exactly 5 correct, I'm guessing what your calculator shows is something like this. 9.7656 something something something. And then it has E and -4 like this. Does that look about right? This is scientific notation. When you see that E right there, that is 10 to the power of whatever this number is. That tells me that the decimal point got moved. And that negative tells me that I have to move that decimal point to the left. That's the negative telling me left. And it tells me how far I have to move it. That's the 4. So I'm going to take this decimal point right here, and we're going to go 1, 2, 3, 4 spaces over. So here's my new decimal point. For those empty spots, we're going to fill them in with zeros. So 0.0009, or I could round that to what? 0.001. Do you guys remember how to calculate the mean using a table? How to calculate the standard deviation using a table? All right. How can I calculate the mean without using the table? What kind of work would I need to show for this? Yep. Multiply the number correct by the probability, and then what do I do with all of those products? Add them together. Either use the table or multiply the number correct by the probability and add them all together to get the mean. I want you to do standard deviation 2. Number 1, you do need to show the work, so go ahead and write it all out, but then you can use the table to actually do the calculating. Does anybody have an approximate mean? Yes. I got something close to that, but a little bit smaller. No. What'd you say? I got 1.25 when I rounded out to 2 places. My guess would be something got entered wrong in the table. You might want to double check your table numbers there. How would you interpret that 1.25? What does that mean? What'd you say? No, tell me what you said. The average number of correct answers Always? In every situation? In the long run, after many, 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 many quizzes just like this, right? So after many, many, many quizzes, the average number correct is 1.25 questions in the long run. We got to do this over and over and over and over and over. For a binomial setting, there is a shortcut for how to find the mean. We had to round each of these probabilities in our table. So that 1.25, that's already a little loose, right? Since we had to round to get our probabilities. The way I can get the precise mean for a binomial distribution is by doing n times p. What was our n value? 5 questions. P was 0.25. What do you get when you do 5 times 0.25? 1.25 exactly. You get the formula right here on the formula sheet. You do not have to memorize that. It's on the front page. It's like smack dab in the middle of the page. It says for a binomial random variable, and then there's a column that says mean, and it has n times p. Yes. If it's binomial, you don't have to do all of that. If it's not binomial, you have to do the mean like that. Yes. What'd you guys get for the standard deviation? I got 0.068, 0.0968, sorry. 0.968. I cannot speak to. I got all the right numbers and not the right decimal spot. 0.968. How would you interpret that? That sounds perfect. The number of correct on a quiz typically varies by about 0.968 or 0.969, depending on where you rounded. Questions from the mean of 1.25 questions. There's a reason that my standard deviation is just a little bit different than yours. Because again, you use the table up here, which already has those rounded probabilities. Just like with the mean, n times p, for a binomial random variable, I have a more direct way of calculating the standard deviation. It is the square root of n times p times 1 minus p. This is also on the formula sheet. So for our problem here, to find the standard deviation of x, what I did is I did the square root of 5 times 0.25 times 0.75. And that gave me a more precise standard deviation. I want you guys to do numbers 7 and 8. Number 7, calculate the probability of getting at most 3 questions correct. And then for number 8, what is the probability of getting 3 or more correct? Please do numbers 7 and 8. what do we need to do to find the probability of getting at most 3 questions correct? What do I need to do to calculate that probability? Yes. Yep. So we're going to add the probability of getting 0 correct, plus the probability of getting exactly 1 correct, plus the probability of getting exactly 2 correct, plus the probability of getting exactly 3 correct. And what do we get? What'd you say? 0.985. Because this is a binomial random variable, I have a shortcut for this on my calculator too. Do you guys want to see it? Okay. Instead of binom PDF that gave me the probability of exactly a certain number of questions right, we're going to use binom CDF. So second and vars, we're going to go 1 option lower. Again, on the app, this is a paid function. On the yellow calculators from my room, binom CDF is option B. 5 trials. Probability of success was 0.25. We want it to be less than or equal to what? 3. That's what we put in for the x, and it's always a less than or equal to. The calculator cannot do a greater than or greater than or equal to. It can only do less than or equal to. And then we're going to paste that in. Should look like this. And then we're going to hit enter. 0.984. Really close to that other answer of 0.985, right? .984, 0.985. What is the probability of getting 3 or more correct? How would I calculate this? Thinking originally, before I showed you any of those other functions. Yep. Add the probabilities for exactly 3 correct, 0.088, exactly 4 correct, 0.015, and exactly 5 correct, 0.001. And you end up getting what? 0.103, 0.104, depending on where you rounded things. You should get about 0.104. I want to use the calculator to do this one too, but I have a problem because this is a greater than, right? My calculator only does less thans. So I'm going to have to figure out another way to write this. Instead of adding these 3 together, what else could I have done? I could have subtracted. I could have done 1 minus and add all the ones that are less than this, right? What are the things that are less than 3? 0, 1, and 2, right? So I could do 1 minus the probability that x is less than or equal to 2. If I have a situation that's a greater than, the way I turn it around so that I can put it in my calculator, it's 1 minus the probability that x is less than 1 lower than this. So I'm going to pop that into my calculator like this. And you can type it in just like it looks there. You can do the 1 minus and then do the binom CDF right on the same screen. You don't have to wait and do the minus part after you calculate this. You should get the exact same answer, or relatively close. Let's flip this over. I threw a lot at you today. We have like 7 minutes left. I'm not going to be able to get through everything, so what we don't get to check your understanding, we're going to do that in class tomorrow in our virtual time together. It will not take all 24 minutes. Things that we talked about today, though. Using our technology. Binom PDF is when we have an equal sign. binom CDF is specifically whenever we have a less than or equal to. Has to be a less than or equal to use binom CDF. For mean and standard deviation for the binomial, we do n times p. For standard deviation, the square root of n times p times 1 minus p. Do you guys want to start on the check your understanding and see how far we get? Or do you want to hold off until tomorrow? All right, I'm hearing more. Let's go ahead and get it started and see how far we get. We still have 5 minutes. We might be able to get halfway through it. Are you more likely to win a random drawing if you crinkle the paper that contains your name before putting it into the drawing box? A curious student conducted a study to investigate. The student took 100 equal-sized slips of paper and crinkled 20 of them before putting them all into a box. After mixing well, they asked an uninformed person to select a winner at random. The student noted if the slip was crinkled. The slip was then returned to the box, mixed well, and the student then asked another uninformed person to select a winner at random. This process was repeated 10 times. We're going to let y equal the number of times that a crinkled paper was selected. Is y, the number of times a crinkled paper was selected, is that binomial? What are the 4 things we need to check again? Binary, independent, fixed number of trials, same probability of success each time. Is this binary? Yes. What is success in this case? Crinkled paper. Failure? Non-crinkled paper. So we get binary. Do we get independence? Yes, the slip was returned to the box. So the next person has the exact same situation that the first person did. Each drawing does not affect the next. Is the number of trials fixed? Yes. What is n? 10. This process was repeated 10 times. So we have independence, we have fixed number of trials. Do we have the same probability of success each time? Yes. What is p? 0.2 or 20 out of 100. So is this a binomial random variable? Yes. Since it's binomial, I have a shortcut for how I can calculate the mean. How do you calculate the mean on binomial? N times p. So take 10 times 0.20, and what do we get? 2. Sorry, everybody's so quiet I can't quite hear it. So the mean is 2. How would you interpret that mean? You said after many groups of 10 trials or groups of 10 drawings, the average number of successes, which in this case would be crinkled paper, so the average number of crinkled papers is 2 in the long run. After many sets of 10 drawings, the average number of crinkled papers is 2 in the long run. I think we have enough time to do part C, and then we're going to have to hold off on the other 2. How do we calculate the standard deviation? Let's use that formula. What's the formula? Square root of n times p times 1 minus p. N is 10, p is 0.20. What is 1 minus 0.20? 0.80. So the square root of 10 times 0.2 times 0.80 would give us what? I got 1.265, ballpark-ish. If you rounded it to 1.26 because I had to round to get that 5, that's fine. How would you interpret that then? The number. The number of successes. In this case, a success is a crinkled paper. So the number of crinkled papers typically varies by 1.265 from the mean of 2. Dude, we can totally finish this up if you want to. Probability of getting 5 or more crinkled papers. What would I use? Can I do greater thans on my calculator? I can't do a greater than, so what would I have to do instead? 1 minus what? Probability x is less than or equal to 4. Pop that in your calculator. It's going to go in like this. Does anybody have a value? Yep, 0.033 or 0.0328, depending on where you round. The reason I had you calculate that is that the student that did this experiment, they ended up having 5 crinkled papers out of the 10 draws selected. Does that provide convincing evidence that crinkling the paper makes you more likely to win a random drawing? What's our threshold? 5%, 0.05. Is this statistically significant? Yes, it is. Right. Tomorrow, if you can't get into the meeting, the password and the meeting ID are posted on our main Canvas page. So you can go to teams.microsoft.com, log in there, and enter with a code. I'm going to take attendance. You guys can stay to ask questions. But since we got all the way through this, there is no actual lesson coming.